Welcome to Lesson 2 in the series CAD for Physicians. In Lesson 1, we learned how to design the shaft of a pedicle screw using parametric modeling. In this lesson, we will design the screw head and the set screw to hold a rod. So go to your data panel and find where you saved your work from Lesson 1 and follow along with us. We will start by making the neck of the screw using a series of simple extrusions. Say extrude, select the top face, extrude it 2 millimeters, type in 2, make sure it's creating a new body, and press OK. Then say extrude again, click the top surface, another 2 millimeters. This time we're going to create a taper angle of 40 degrees. Make sure it's joining the original body and press OK. Let's look at the front face. Let's give the screw head a different color so we can recognize it. Go to Modify, select Appearance, go under Metal, select Titanium. Titanium polished will give the body of the screw a nice titanium polish, and then select titanium polished, right click on it, say duplicate, double click on the duplicate, select a different color and press done, then drag the new color onto the screw head. Press close. Alright, from now on our body is going to be purple. Grab a circle, click on the top surface, click on the center, draw it out for 10 millimeters, press return, return, stop sketch. Let's extrude that circle, say extrude, make sure you grab both of these profiles and drag it up 10 millimeters. And make sure it's joining your previous bodies. Press OK. This is the general shape of our screw head. Now let's do a little refinement. Click on Fillet. Click on this profile. Fillet it, let's say 3 millimeters. Press OK. Now we need to create a facet on each side of the screw head so that an instrument can grab it and stabilize the screw head as it's getting screwed into the bone. So go under Sketch, grab Center Rectangle, click on the top surface, click on the center, pull it out. Let's say the first dimension is 10. Press Tab. The second dimension is 9. Press Return. Return. Stop sketch. Let's look at the top surface. Zoom in. Now you can see we can do a negative or subtractive extrusion. Press Extrude. Grab this little piece and this little piece, and let's extrude them down and make sure the operation is cut. Press OK. So now we have created a nice facet on each side of the screw head for grabbing it. Next, we need to create a slot to fit a 5 millimeter diameter rod, and the top of the rod should be 3 millimeters below the top surface of the screw. So go to the front view first. First, we're going to create a construction line. So grab a line, click on the coronal plane, let's reposition, zoom in, and draw a horizontal line through your screw head. Press the check mark, press escape. Now select that line and press X. That'll turn it into a construction line. Now we want this construction line to be 3 millimeters below the top of our screw head. So press D, which is our dimension tool, zoom in, click on the top corner of the screw head and on our dimension line, and then drag it out. It says 5 millimeters, type in 3, return, and that has repositioned our construction line. Press escape. Next, we're going to draw a circle below this construction line with a diameter of 5 millimeters. So go to Sketch, grab 2-point circle, click on the construction line right at the midpoint and press your first point, drag down and type in 5, press return, return. Alright, now we have a circle for the profile of our rod. Next we need to create the vertical slots. So grab a line, draw a vertical line on one side of the circle, press escape, grab the line again, draw another vertical line on the other side of the circle, press escape. Now we have to make sure that both of these vertical lines are tangent to our circle. So first we're going to fix our circle. Go to the fix constraint, grab it, click on the circle. This way it won't move. Then go to your tangent constraint, click on one of the lines and the circle, and then click on the other line and the circle. Good. Now we're ready to extrude. Stop sketch. Go to extrude. Select this profile and this profile and make sure it's cutting. Let's reorient. We can do a symmetric extrusion and just pull it out to make sure it cuts all the way through and press OK. Very good. Now we have our screw head. We need to create a recess for the screwdriver in here. So go to Sketch, grab Polygon, circumscribe polygon, click on a flat surface on the top, click on the center point, draw a polygon, let's say diameter of 1.5, press return, stop sketch, let's extrude that down, so extrude, select the surface, drag it down to 10 millimeters, negative 10 millimeters. Make sure it's cutting and press OK. That's our screwdriver recess. Next, we need to create a set screw and threads. So we want the thickness of our set screw to be 3 millimeters. So let's select a circle, select the top surface, select the center, draw a circle that is 8 millimeters in diameter, press return, return, stop sketch. Let's extrude that down 3 millimeters. extrude, select all of the appropriate profiles, cut down 3 millimeters, type in -3, make sure it's cutting, and press OK. Good, now that has created a recess for our set screw. Let's create the set screw itself. Let's reveal the circular sketch that just disappeared, and let's re-extrude. So extrude, select both of these profiles. Let's extrude up 3 millimeters and make sure it's a new body and press OK. Now we're ready to assign our threads to the set screw and to the screw head. So go to Create, find the thread command. The face to select is right here, and make sure you have modeled on, and make sure you select Remember Thread, because we want to apply the same thread to the screw head. It looks like a pretty good thread, so we will leave all of the default parameters here and press OK. That looks good. So now we want to apply the same thread to the inside of our screw head. So go back to Create, say Thread, and for the face, just select the inside, and it has remembered our previous thread. So just press OK, and now we have created matching threads. Lastly, we want to create a recess for the screwdriver on the top surface of the set screw. So again, go to Sketch, grab Polygon, circumscribe Polygon, click on the top surface, click on the center point, and again draw a 1.5 millimeter radius polygon. Press return. This way we can use the same screwdriver to screw the set screw and the pedicle screw itself. Say stop sketch, and we're going to extrude that down. So grab that profile and go down 2 millimeters and make sure it's cutting and press OK. Let's paint this set screw the same way. So go to Appearance and grab your purple and apply it. Hide all your sketches. Hide the origin. So we're done with our pedicle screw design, but let's not stop here. Let's create a cylindrical joint to show how the set screw screws onto the pedicle screw head and how it holds onto a rod. To learn more about joints, you can go to our other tutorial series, Fusion 360 Simplified, and it's in lesson 3 of that series. You will learn from that lesson that the first thing we need to do is to redefine our bodies as components. So let's look at our bodies. We have 3 bodies. The first one, you can hover on it, that's the shaft. So let's rename it the shaft of our screw. The second body is the head. So let's click, rename it the head. The third body is the set screw. Click, set screw. Shift, select all 3 of them, right click, and say Create Components from Bodies. Now they have been converted to movable components, and we can create joints. Go under Assemble and say As Built Joint. It's an as-built joint because the positions of our set screw and the screw head are already pretty optimal. And the components to select are these 2 components, the set screw and the screw head. And the type of joint we want is a cylindrical joint that both revolves and translates. So cylindrical. And the position is the axis of rotation. So say select, let's look at the top, and select the center point as the axis of rotation. And press OK. Next, we need to define a relationship between the rotation and the sliding component of this joint. So go under Assemble and say Motion Links. Select the joint. We go under our browser and find our cylindrical joint. That's the joint that we want to edit. And we want to link within the same joint the sliding component to the rotational component. So we're going to link within the joint. And we want the joint to operate such that for every 1 millimeter of slide, so change distance to 1, it turns 360 degrees. And press OK. Now, if we want to see how this joint actually moves, we need to stabilize the base so that we can turn the set screw. That's very simple to do. Go to the head component, right-click on it, and say ground. So that's grounding the head. And now I can just grab the set screw and rotate it, and you can see how it screws in. The problem is that it screws in too far. So I have to create limits for my joint. So let's revert to the original position and go to the joint, hover on it. That's our cylindrical joint. Click on this little arrow, and that'll allow me to set a minimum and a maximum range for either the rotation or the sliding movement. So let's go to the sliding movement, and let's say the minimum is 0 and the maximum is 3. Well, it's going in the wrong direction, so let's change things around. Let's say the minimum is minus 3 millimeters and the maximum is 0. We can animate that movement. That looks pretty good. Press OK. We can hide the sketches that correspond to the joint. Finally, let's render this screw. So go to the render workspace, zoom in, and here you can set your lighting, and you can apply different colors if you wanted to, and you can do an in-canvas render, or you can do a cloud render which has higher resolution. The rendering is finished and we're done with our lesson. In the next lesson, we will learn how to capture real anatomy from the CT scan of a patient so that we can screw our design screw into it.